Okay, hello, my name is Reginald Seay, and I'll be going over a question about a system, and it asks find the transfer function from V in and V out, assuming zero initial voltage for capacitors, and also find the impulse of the system. Okay, so this is our circuit that we have, which is our system. Has a V in, an op amp, it's two capacitors, and two 1 ohm resistors. Well, yeah, three 1 ohm resistors. Okay, so to start off this problem, we look at our circuit, and then we can say that we'll first find our V plus. And we'll find the V plus by using voltage division. And voltage division is, I don't know if any of you have taken circuits 1, but it's basically a way to simplify your circuit by doing just a little bit of algebraic manipulation. So we'll find the V plus, which is the voltage going into the positive side of our op amp in the circuit. Okay, and then we'll say our V plus, which is the voltage going into the op amp. Sorry about that. Kind of messed up that V. Alright, so we're going to say our voltage, I'm going to circle it in red, the V plus. Our voltage, V plus, is going to equal V in, and it's going to be multiplied times 1 over 1 plus 1 over S. Okay, so that's our V plus. And then we can go and simplify it some more. And once we simplify our V plus some more, then we can say it becomes, change back to red real quick, V plus is equal to V in, and that's times S over S plus 1. Okay, so now we have our V plus. Our V plus, again, is the voltage that's going into the op amp of the circuit, the positive side of the op amp of the circuit. So basically we're assuming that this is an ideal op amp. Okay, so it says, so we can say now we can find the current of the left-hand resistor for the ideal op amp, and we're assuming that it's an ideal op amp, so we can say that the current of V plus is equal to V minus. Okay, so now we're going to find the current I in the left-hand resistor. Left-hand resistor using, oh, sorry about that. Alright, using the rule for ideal op amps. And that's just saying that the current going into V plus, which says that the current in V plus is equal to V minus. Okay, so that's just a little bit of circuits background in case any of you people didn't know or haven't taken circuits. I didn't want you to assume like, oh, where'd that number come from? How did he find I? Well, this is how I found I. Okay, so given that background information, we're going to find our I now. and I'm gonna put the current in blue. I feel like our current should be blue. Yeah. Okay, so our current I is going to equal V in minus V minus over 1 ohm. So this is the V minus, which is the negative, going into the op amp, the V minus of the op amp, and the V in is the voltage that's the initial voltage of the source in our circuit. And then we can say that that is equal to 1 minus S over S plus 1 times V in. And then just doing some more little manipulations, we can say that I is equal to 1 over S plus 1 times V in. Okay, so what we have now is we have what V plus is equal to, and we also have what I is equal to. And we found our V plus by doing voltage division, and we found our I by doing a background analysis of the circuits, knowing that it's an ideal op amp. Okay. So we know that the current I flows through the 1 farad capacitor, and it also flows through the 1 ohm resistor. And also the 1 ohm resistor. Okay. Now, knowing that, we can also say that they're both in parallel. So, looking at the circuit, the 1 farad capacitor and the 1 ohm resistor are both in parallel. So if you look at the diagram above the op amp, you can see that the C1 or the capacitance and the resistor are both in parallel. So that just basically means that we can write an equation for both of them now that we know our current. Okay, so now we can say that for our 1 farad capacitor in parallel with the 1 ohm resistor, that V in times 1 over S plus 1 times 1 over S in the numerator, and in the denominator we have 1 plus 1 over S, and that is equal to just simplifying it, V in times 1 over S plus 1 squared. Okay, so now that we have that, we can say our V out, which is the voltage that's coming out of the circuit, like the exiting voltage, is equal to V minus, and that's minus V in times 1 over S plus 1 squared. And simplifying that gives you V in times S squared plus S minus 1 over S plus 1 squared. Okay, so now that we have that, that second half will be our transfer function. So we basically have our transfer function now. So we can say that h of s, our transfer function h of s And h of s usually represents the transfer function. If you ever see a h of s equal something, h of s is equal to s squared plus s minus 1 over s squared plus 1, s plus 1 squared. And then just breaking that apart into individual parts, you can say it's 1 minus 1 over s plus 1 minus 1 over s squared, 1 over s plus 1 squared. Okay, so there we go. There's our transfer function. Okay, and now to find our other function, which is our impulse, we do the inverse Laplace of it. So do the inverse Laplace of h, and we have it. So we can say our h of t is equal to the Laplace inverse of h. Which is equal to delta t minus e to the negative t minus t e to the negative t. And there we go. Alright. We have found our transfer function and our impulse function. Impulse response. Thank you for watching.